We're going to be taking a look at the alkenes now. So if we were to take a look at this molecule in the top left, if we count the carbons, we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. So this is an octane. The double bond is on the far left, and we start numbering the carbons from this side. So the number 1 carbon would be over here. So the octene itself is on the 1 position. So we know we have an octane. We're going to change that name to octene, and it is in the 1 position. So we can either call it a 1-octene or it can be an oct-1-ene. Moving over to the second compound, we can see we've got, again, 1, 2, 3, 4, 5, 6, 7, 8. Again, this is an octane. There is a double bond in the 2 position now, so 1, 2 into it. And so this changes the name then, obviously, from an octane to an octene. And in the 2 position now is where the octene is. But the main difference between these two is now there's a stereochemistry associated with this. At the end here, these carbons, essentially, in terms of the naming convention, had 2 hydrogens hanging off. And those hydrogens, in terms of atomic number, were equivalent. So there is no E or Z naming that's required for this one. But for this one there is, and we will have to start to do the naming for that. So to do the naming, we can just look at either side of the double bond. I always like to redraw it. So if I have a carbon here, so this carbon I'm going to refer to here, and this carbon will be this one. So we can see on the way down there's another carbon essentially here. That's this carbon. And what we got to know is that there is a hydrogen hanging off here. Although it's not explicitly shown, there is a hydrogen hanging off here. Similarly, up here there's a carbon. So here I'm going to draw a carbon. And hanging down here is a hydrogen. So I'm going to draw a hydrogen here. So across this double bond, if we were to call this a 1 and a 2, this is numbering is not to do with the actual original numbering of the parent system. This is just not to confuse the 2 carbons across a double bond. So on the first carbon here, I take a look at the atoms that are attached to it, and the atomic number for carbon is higher than the atomic number for hydrogen. So I give it a 1 here and a 2 here. And on the other side of it, I've got the atomic number for carbon here is higher than the atomic number for hydrogen. And since these carbons, essentially these number 1s, are opposite each other, they're not on the same side, they're not on the same side, we would call this an E conformation. So if the numbers, the higher atomic numbers, were both on the same side, or as my students like to say, the same side, then it would be a Z conformation. It's an easy way of remembering E and Z. So we now know that we have an E conformation for this. And now to go back for the full name again, I will call it an oct-2-ene. So it tells me there's 8 carbons, in the 2 position is a double bond, but I also need to introduce the stereochemistry. So out front, in the 2 position, it is an E conformation. I'm going to put it in brackets and a dash here, and that finishes off the name for that compound. So in the third compound we again have 8 atoms in a row, So this is also an octane. Again, we see the double bond is on the 2 carbon here, but we can see that the conformation is changed. So in some of the old common way of naming, we would probably call this a trans bond, and this would be a cis conformation. But we're using IUPAC, and in the IUPAC we're using the E and Z. We've already done it and applied it onto this one, so we're going to apply it to the next compound here. So it's an octane. We're going to change that name to an octene, and in the 2 position is where the octene is going to be. So I'm going to call this a 2-octene, or an oct-2-ene. Now to go for the E or Z conformation, we have to recognize that there are hydrogens on the across the double bond. So based on atomic number, I've got this carbon versus this hydrogen. this carbon versus this hydrogen. So the carbon here is higher atomic number, so I'll give it a 1, the hydrogen a 2. This carbon is a 1, this hydrogen is a 2. Since these are on the same side, this is a Z conformation, and they're in the 2 position. So to finish out the name here, I would put a 2Z octene, or a 2Z octuene. And for our English friends, for our American friends, I'll say it's a 2Z octuene. So we have another octane here that contains double bonds. So if we look, we have 1, 2, 3, 4, 5, 6, 7, 8 carbons in a chain, and we have 3 double bonds within it. So this is actually an octatriene. So I'm going to write down first octane, and then I know that this is going to be an octene. And because there's the 3 double bonds, this is going to be now called an octatriene. Now it's odd that this A pops into it, but it's mainly because I've got this, I need a vowel in between the 2 T's here. I couldn't just have a T and a T, so they push this in. So it's an octatriene. Now I need to know the positions of the double bonds. If I start from this carbon, 1, 2 in, there's a start of a double bond. If I start from the other side, 1, 2 in, there's a double bond there. So they're equivalent on that side. And if I start 1, 2, 3, 4 in from this side, or 1, 2, 3, 4 in from this side, we can see there's a very symmetrical molecule, so it actually doesn't matter potentially which side we start from. So starting from this side then, because it's just easier for me, at the 2 position is a double bond, 3, 4 position is a double bond, and at the 5, 6 position is a double bond. So I can call this a 2, 4, 6 octatriene, or I can call it an octa 2, 4, 6 triene. Now the problem is though we still don't know the stereochemistry, and that's going to go out front here. So if we take a look at each of these, so starting from the 2 carbon here, if I look, I've got the H's, they're on the same side, and the carbons here are on the same side. So the 2 position is a Z, or a Z for our American cousins. In the 4 position then, I have an H here, I have an H here, they're on opposite sides, so this is an E. And in the 6th position, I have a hydrogen here and a hydrogen here, they're on opposite sides, this is also an E. So it's a 2Z, a 4E, and a 6E. And so in order to write that, I'll put a bracket here, and I will put the 2Z, comma, 4E, comma, 6E. And so this will tell me that I have an 8 carbon chain. I have 3 double bonds. They are in the 2, 4, and 6 position. And as well, the 2 position is a Z conformation, the 4 position is an E conformation, and the 6 carbon double bond is an E conformation as well.